let's see if I can talk about this lesson in 15 minutes or less. This is 13.2, general angles. Of course, I left a lot of text in here. It says angles, and of course we have the definition of an angle. It's formed by the intersection of two rays, typically measured in degrees or radians, both of which are based on the measure of a circle. Angles in standard position have the positive x-axis as the initial side, so this is always my initial side. And then if we're going to rotate positively, we rotate to a terminal side. Now, I did an angle that's about 135 degrees, or 3 pi over 4. Okay, it's roughly 135 degrees, or 3 pi over 4. Positive angle, and I should have this text auto-completed behind this little box. Let's hope I do. It rotates in a counterclockwise manner. If you're not sure how a clock rotates, this would be counterclockwise. And if a positive angle rotates in a counterclockwise manner, then a negative angle must rotate in a clockwise manner. So if we talk about a negative angle, it would rotate just like a clock hand. Start here, and it would rotate to a terminal side. Notice I'm drawing in the arrow for rotation. This is roughly negative 135 degrees, or negative 3 pi over 4. All right, draw an angle with a given measure and show the rotation. I must see the rotation. I'm tired of kids being lazy on these assignments. Negative 50 degrees would rotate like a clock. And it would rotate just a little more than half of that quadrant. And again, you show the rotation. That's negative 50 degrees of rotation. 240 degrees, hopefully you guys have kind of mastered the unit circle by now, would rotate 180, right? That's 180 degrees. I don't know why I did that last drawing. And then rotate about 60 more. And there's my angle, 240 degrees of positive rotation. The 600, when you draw a 600 degree angle of rotation, of course you always start out on the positive x-axis. You're going to rotate a full circle. So you're going to take away that 360, and you're going to rotate 240 more. It's actually in the, that's not far enough, is it? A little more. It's actually exactly the same as 240 degrees. But you got to show the rotation on these. You're learning how to draw. Coterminal angles are angles that share the same terminal side. That's all they are. That's all they are. Now, let's just use that 200. I just had an example of coterminal angles. If you look back here, 600 and 240 were both coterminal, and you'll see that they differed by 360. Let's let theta be a negative 120 degree angle. That'd rotate 90 and about 30 more, which is also coterminal with 240 degrees. So if you're catching on to here, coterminal angles, they differ by 360 degrees, or 2 pi rads, okay? We've kind of talked about 2 pi rads and we haven't, but we should know that 2 pi is 360. All you have to do is plus or minus 360 degrees to find a coterminal angle. All right, so coterminal with 50, you could do 50 plus 360, which is 410, or you could do 50 minus 360, which is negative 310 degrees. They're really not that hard. And you could keep going. You could add another 360 and get 770. And you could keep taking away 360. You could take away 360 again and get negative 670 degrees. Just add or subtract 360. Coterminal with 240, if we add 360, we'd be at 600. We've already done that one. If we take away 360, we'd be at negative 120. Kind of did that up here. And you can kind of see that these are the same exact questions. 240 is coterminal with 600, as is 960 degrees. Just add or subtract 360, really easy. All right, radian. A radian is the measure of the central angle that creates an arc length equal to the radius of the given circle. So if you have a circle with radius r, and you end up with an arc length, which we're going to talk about in tomorrow's lesson, and it's also r in length, you have created what's called 1 radian as a measure at the center. Now, 1 radian is about 57.3 degrees, that's what it is. And it has a really easy thing to memorize. 1 radian is 180 over pi, which is roughly 57.3 degrees. This text it's not on there because we hadn't done a form quiz, so just kind of cross that out. I'm not planning on doing a form quiz. Take 180, we divide that bad boy by pi, and you'll get something that's really close to what 1 radian is, about 57.3 degrees. All right, moving forward. The pi radian. By mathematical definition, 1 radian is 180 degrees over pi. Cross multiplying, saying 1 radian is 180 over pi, we get that a pi radian is 180 degrees. So a pi rad is 180 degrees, and by the time we have this lesson, you guys should have done the unit circle 3 times already. 2 that I've graded, 3rd one that you just took to be returned to you. So you should already know most of this stuff. And 2 pi is 360 degrees. All right, formulas. Convert the following measure in degrees into radians. And these, a couple of these you should already know. Like right by now, you should already have memorized that 30 degrees is pi over 6. And you should have already memorized that 45 degrees is pi over 4. But to convert from a degree into a radian, you're going to take your degrees, and let's just use x. X degrees, what we want is we want the degrees to cancel out, so we have to have the degrees over the bottom and the pi rad up top. We multiply by pi over 180. So 600 turned into a pi rad is 600 times pi over 180. And I'm going to go old school here. I'll show you how to do it in a calculator, but the zeros cancel. 60 and 18 are both even, that's 30 and 9. Both of those will by 3, which is 10 and 3. 10 pi over 3. Now, for you lazy kids, which is what you are, you just kind of don't put the pi in the calculator. So 10 times 1 over 180, back is a frac, 10 pi over 3. Negative 540, same idea, we multiply by pi over 180. Zeros cancel. And 18 enters 54 3 times, so negative 3 pi rad. We abbreviate radian, RAD. I don't like to write it. All right, moving forward, convert the following radian measures into degrees. What we want is we want the pi symbol to disappear to some degree. So we're going to multiply by 180 degrees over pi. So we've got negative 5, and this is one way of doing it. Or we let pi equal 180 degrees because that's what it is. So there's lots of ways of doing this. And I'll show both. So we're going to multiply by 180 over pi. The reason this formula works is because the pi symbols disappear and all we're left is the degree symbol. So 180 over 6 is 3. We have negative 5 times 3, 30, sorry. And we get negative 150 degrees. Now another thing you can simply do is to simply replace the pi with 180. And 180 over 6 is 30. And you still get negative 150 degrees. And I'm actually a big fan of that. I really am. So pi over 2, 180 over 2, which is 90 degrees. 3 pi over 4, if you haven't memorized it already, would be 3 times 180 over a 4, which is 3 45s, which is 135 degrees. And then negative 4 pi, I know that pi is worth 180, and negative 4 times 180 is negative 720 degrees. And that is it for day 1 of 13.1. So we'll finish up 13.1 day 2 tomorrow. It wasn't too bad of a lesson. Let me add something in. Choice E, and E is going to be negative 4.25 rads. Now notice it doesn't have a pi. There's no pi. But we still follow the same formula. We take negative 4.25 and we multiply it by 180 over pi. And it's already kind of an ugly number, so we just kind of have to go with it. Usually when you use a calculator, you don't actually press the pi key. There's always some exceptions to those rules. It's negative 243.51 degrees. That's one way to skin that cat. All right, so there's 13-1, day one. Hope you enjoyed.